Good morning again, y'all, or afternoon, depending on when you're watching this. This is the third video um, of the trilogy series for division of polynomials. So this time, I kind of just want to go over what happens if we have a remainder. So again, I want to kind of relay this back to when we were in elementary school and we were learning long division. Again, we were trying to see how many times could we put our divisor into an integer. So how many times so we're going to go ahead and break this down. So we're going to divide 2,836 by 7. So how many times can 7 go into 2? Well, it can't go into 2, but can it go into 28? And it can go in there 4 times. So then we're going to do 4 times 7. This happens to be 28, so that cancels. Bring down the next number. Can 7 go into 3? No, but let's bring down the next one. So can it go into 36? So it can't go into 3, but it can go into 36 5 times. 5 times 7 is going to be 35. And we're left with a remainder of 1. And in this case, then we would turn this into a decimal. You put a decimal point and put a bunch of zeros and see how much we'd go to turn into decimal. Or you may have also been taught to just do remainder of 1. And what this is actually just saying with a remainder of 1 is actually just saying 405 plus 1 over 7. 1 divided by 7. We could also write it as that. That's the same thing. Or if we were to add over whatever 1 divided by 7 is, that would just be added on as our decimal place. And the reason I bring this type of notation up is this is the type of notation you would use when we're dividing polynomials. So if we were to have a polynomial that had a remainder, and I'm going to do this twice, one with a monomial and then one with dividing using a binomial. Actually, I'll just do a binomial. It's the and we're going to do so we're going to take p plus 9. We're going to divide that into p squared plus p minus 79. So I've already given the hint or the surprise away, but there is going to be a remainder. So again, just like how we were dividing the binomials last time, we're going to look at p, and we need to ask ourselves, what do we need to multiply p by to get to p squared? We're going to multiply by p, and then you're going to take that term, and we're going to do p times p plus 9. And so p times p is p squared. P times 9 is 9p. And then we're going to do the inverse and subtract. P squared minus p squared, 0. P minus 9p is going to be negative 8p, and bring down the rest. So now we need to look at, what do I need to multiply p by to get to negative 8p? I'm going to multiply that by negative 8. Negative 8, oh, and let me show that. So we're going to take negative 8, and we're going to multiply that by p plus 9. So negative 8 times p is negative 8p. Negative 8 times 9 is negative 72. And we're going to subtract. So we're going to subtract these two, negative 8 minus negative 8. So that's negative 8 plus 8. I'm sorry, negative 8p and plus 8p. So that's going to be 0. And then negative 79 minus negative 72. So negative 79 plus 72 is going to be negative 7. Well, now we hit a snag because we can't times anything times p to give us negative 7. It doesn't have a variable. So when you're left with a remainder, you write the sign. So if it was ooh, I am very sorry, y'all. You write the sign. So if this was a positive, you'd write plus, and since this is a negative, we're going to write minus what the remainder is. In this case, it was 7, and put it over what we were dividing by. So 9, I'm sorry, p plus 9. And this would be our answer. Now to do the check though, what you need to do is that you're going to multiply, this is for your check, just to see if you got the right answer. So for your check, you would take what we divided by, and then what we got as an answer out in lack of a better word, whole. So what we don't have to write as a fraction. You're going to multiply. So this would come out to be p squared, and I'm just doing this very quickly. You can pause and do that really quick in your head. This is b plus p, and this is going to be negative 72. You notice that they don't match up. What you need to do at the end is add this remainder. So you need to add a negative 7, that's what the top is. And when you do that, you get the right answer. Now, you're going to ask, but Mr. Parker, why do we not add negative 7 over 9? I'm sorry, negative 7 over p plus 9. Well, the problem is that you're actually having that here, and it's much easier to do it that way, to do it where you tack it on the end, because that way you don't have to worry about doing this. So what would happen is that you actually have that remainder there. So I'm erasing this. That remainder's there, but p plus 9, so if we did negative 7 p plus 9, and we multiply that by p plus 9, this is p plus 9 over 1, p plus 9 divided by p plus 9, that cancels, right? So there's our negative 7. So that's why you just tack on the end. Whatever you divide it by, when you multiply that back into your check, it cancels out the fraction. All right? And that's why another rule is that, like, the distributive property or method of multiplying polynomials may help with seeing that as well. So to kind of show it in that term, as you may have just thought of foiling, well, you can also see it as p plus 9 times p plus p plus 9 times negative 8 plus p plus 9 times negative 7 over p plus 9. That's another way that you could have, instead of doing the foiling, since we're doing that, that's another way to look at it. We went over this over multiplication of polynomials, so if you need to, I'll put a little tag at the top at this point just to kind of show y'all that you can go back and look at that video to kind of help you see the distributive property way of multiplying polynomials. But this is what you would do if you have a remainder. What I'd like you to do is I'm going to write another problem out. I'd like you to pause it, and then I want you to solve it yourself, and then see if you get the same answer. Take your time with it, and then come back and check. So we are going to do k, well, let's actually write this one. So k minus 3. Put this into k squared minus 4k plus 11. So again, we need to whoops, almost started giving it away. So again, pause here, solve it on your own, and see if you get the right answer. Alright, so now that you're back, so what do we need to multiply k by to get k squared? We need to multiply by k. K times k is k squared. K times negative 3, negative 3k, and then we're going to subtract. K squared minus k squared cancels. Negative 4k minus 3k, negative 4k actually plus 3k is another way to write that, so we would then have negative k, or negative 1k if you'd prefer, plus 11, What do I need to multiply k by to get to negative k? Well, just negative 1. Negative 1 times k, negative k, negative 1 times negative 3, positive 3, and we're going to subtract. Negative k plus k, because this is now going to be a double negative, so that would cancel out. And then positive 11 minus 3 is going to be positive 8. Okay, so we have a remainder. So then you're going to tack on the sign, it's positive. You're going to write the remainder over what we divided by. And this would be your answer. Hopefully that helps. Again, check to see if you can see your mistake. If not, you can send me an email and we can work that out. Hopefully you're doing well, and I'll talk to you soon.